Another function operation uses the output from one function as the input for the second function. This operation is called a composition of functions. In other words, you're taking one function and plugging it into the other function. So the composition of functions f and g is denoted by f of g of x. In this case, you're going to take the second function that is said and plug it into the first. So you're going to take g and plug it inside of f. So the domain of f of g of x is a set of all numbers x in the domain of g such that g of x is in the domain of f. And again, it is read as f of g of x. In this example, we are given the functions f and g and asked to find f of g of x. That means since the function g was last mentioned, this is the function we're going to plug into the first function. So we're going to take g and plug it inside function f. So into the f function where the x is, you're going to remove the x and you're going to replace it with what g of x is, which is in this case is x squared plus 2. Again, taking the g of x function and plugging it into the f of x function. When we do so, it's going to look like so. All we need to do now is distribute the 2. That's going to be 2 times x squared, which is 2x squared, and then 2 times 4, which is, 2 times 2, which is 4. And so f of g of x then is going to equal 2x squared plus 4. In this next example, we're asked to find the opposite, to find g of f. So notice that f of x is the last function that is mentioned, and this is the one we're going to take and plug into the first function. So where the g of x function is, we're going to remove the x here and replace it with what f of x is, which is 2x. So again, we're going to take the f of x function and plug it inside the g of x function in x's place. When we do so, it's going to look like so. Now all we need to do is to use the power rule and raise each number inside to the power outside. So that's going to be 2 squared and then x squared. Let's solve the numeric part. 2 squared is 4. So our final answer is 4x squared plus 2. So g of f equals 4x squared plus 2. In this next example, we're given two functions, the f and g, and we're asked to find f of g of x, which means we're going to take the g of x function and plug it inside the f of x function, and then we're also going to evaluate it for 3. Now we can do that all in one. Just take g and plug it inside f, and then in that x's place replace it with a 3. Again, taking g of x and plugging it inside of f of x and then evaluating it for 3. So now we've plugged g inside f. It looks like so. Now we're going to remove the x and replace it with 3 and do the math. 3 squared we know is 9, and 9 take away 4 is 5. So therefore, f of g of 3 equals 5. In this example, we're given the functions f and g and asked to find f of g of x and then find its domain. So here, since f is the last function that's mentioned, we're going to take f and plug it inside of g. So here is the g function. We're going to remove the x and replace it with the f of x function, which is square root of x minus 2. When we do so, it's going to look like so. Again, it is placing f of x inside of g of x. And at this point, there's really nothing more that you can do with this function. However, we are asked here to find the domain of the function, and the domain of the function is all the allowable x values. So we want to know what numbers we are allowed to plug into this function. Since it's a square root, remember you can't have any negative underneath the radical. So what you can have a 0, but you just can't have negatives. So what you should do is set the radical itself underneath whatever is underneath here. Set that to where you want a number greater than or equal to 0. So you don't want any numbers less than 0. So when we set it to greater than or equal to 0 and solve for x, to solve for x we would need to add 2 to each side. And so x would have to be a number that is greater than or equal to 2. And so that's all the allowable values that we can plug in here. We can only plug in numbers that are 2 or greater, because anything less would produce a negative under the radical, and then it would not be a real solution there. So the domain then would be, again, the numbers from 2 all the way to positive infinity. And notice we use a bracket because it does include the 2. You can see there with the line there underneath. It does include 2, and then it goes on to infinity, and we always close infinities with a parenthesis. And there you have it. Okay, your turn. Here you're asked to find f of g of 6. So we are given two functions here, the f of x function and the g of x function. So I want you to pause the video for a moment and see if you can do it on your own. And then when you're ready to reveal the answer, go ahead and restart the video. Okay, let's see how you did. So to find f of g of 6, we're going to place g inside of f. So if f is x minus 1, and we want to plug into that g in x's place, so what we'll wind up with is 1/2 x plus 4 minus 1. Continuing on to simplify this, that would be 1/2 x plus 3 when we combine a positive 4 with a negative 1. And now let's go ahead and evaluate this for 6 by removing the x and replacing it with 6. So give me a moment to get the eraser tool here, and I'm going to plug in a 6 in x's place. When we do so and simplify that, we're going to have 6 over 2 plus 3, and 6 divided by 2, well, my pen here is skipping, there you go, is 3, and then 3 plus 3 will equal 6. Okay, so if you did the equation correct, that is the answer that you should have gotten for that. When we find f of g of 6, it equals 6. And there you have it. Okay, that's it for this lesson. Thank you for watching math videos on PowerPoint with Dr. Speights. I hope you were able to learn something in this lesson. Please feel free to like, share, and subscribe. Bye-bye.